What if everything we thought we knew about the laws of nature, gravity, time, light, was only true in most places, but not all? Scattered across our world are locations so peculiar, so fundamentally at odds with everything we've come to accept about physics, that they force a re-examination of what reality even means. These aren't legends or myths whispered among mystics. They're documented zones studied by scientists, observed with precision instruments, and quietly sealed off by governments. Each one is a scar on the fabric of space and time, a place where nature seems to blink. This story begins not with a bang, but with a drift. A military vehicle, idling on a quiet Himalayan road, begins to roll uphill. No engine, no push, just a slow, steady climb against gravity. At first, it was considered an illusion, but the data kept coming. Objects of every shape and size, even 40-ton trucks, reversed the direction gravity dictated. Something about this 30-kilometer stretch of road refused to obey the most basic rule of all. What goes up must come down. This isn't just about strange hills or haunted forests. It's about regions where time slows down measurably, where a cause follows effect, not the other way around, where mass itself changes depending on position, and where the speed of light, Einstein's sacrosanct constant, is no longer constant. Each place offers a different impossibility, and yet together they point toward a haunting truth. The universe may not be as consistent as we believe. Over the next 13 chapters, we'll journey to locations as diverse as the Australian outback, the Chilean desert, the Canadian wilderness, and underground bunkers in Switzerland. We'll meet physicists, technicians, and anonymous sources who encountered these phenomena not as theories, but as lived experience. We'll see instruments break, readings defy replication, and even time itself falter. These stories are not about proving conspiracy or uncovering cosmic secrets. They are about encountering the unknown with humility and awe. In a sealed chamber in Geneva, magnets pull inward instead of outward. In Minnesota, time flows at a different rate, just meters from a walking path. In Nevada, explosions are recorded before the charges are triggered. These aren't isolated incidents. They're patterns, anomalies, too precise and persistent to dismiss. What if gravity isn't a universal force, but a local agreement that occasionally breaks down? What if entropy, that sacred measure of disorder, can run backward? And what if some rooms on Earth are disconnected not just from global systems, but from the very rules that bind atoms together? This series isn't about fear, it's about wonder. It's about standing at the edge of the known and staring into the silence where answers do not yet exist. These anomalies are not threats to science. They are invitations. Invitations to question, to explore, and perhaps to recognize that our planet still holds secrets, not because we haven't looked, but because we haven't been able to see. So let us begin, not with certainty, but with a question. What does it mean when the universe pauses its rules for a moment and lets us peek behind the curtain? Welcome to the journey, to the places where physics stops working. It began with a whisper of wind and the crunch of gravel under tires. An Indian Army convoy winding its way along the Kargil Highway, 14,000 feet above sea level. The landscape was vast and silent, broken only by jagged ridges of Himalayan granite. Then something impossible happened. A supply truck, left idling in neutral, began to climb. Not roll down, but climb. Soldiers stood frozen as the massive vehicle crept up the incline without power. The hill, later designated the Magnetic Hill of Laida, became the subject of quiet military scrutiny. Soon, engineers brought levels, compasses, and gravimeters. What they found defied explanation. Gravity, the most predictable of all natural forces, was reversed. The effect wasn't visual trickery or an illusion caused by surrounding terrain. Measurements confirmed it. Gravitational acceleration pointed up. From stones to military vehicles, everything behaved as if pulled skyward. The boundary of the anomaly was disturbingly precise. 30 kilometers of reversed gravity marked with mathematical clarity, not a gradual shift, but a hard edge where the rules changed. Even more troubling, aircraft flying overhead at low altitudes reported sudden upward jolts, forcing pilots to compensate or risk being tossed off course. Dr. Rajesh Kumar, a physicist from the Indian Institute of Technology, spent months studying the phenomenon. His instruments recorded an upward gravitational field that fluctuated in strength but never direction. No known material explained the shift. The bedrock was ordinary, the magnetic readings normal. Locals spoke of the hill in reverent tones. According to legend, it was a path to heaven, the resting place of spirits who refused to fall back to earth. But no one could say why it happened, only that it always had. Government reports were quietly classified. Some leaked. They hinted that similar anomalies existed elsewhere in the Himalayas, suggesting a pattern beneath the peaks, a hidden force pulling at the seams of reality from above rather than below. For scientists, the implications were staggering. If gravity could reverse in one place, it meant the laws of mass and attraction might not be as fixed as once thought. Newton's universal law, the one schoolchildren memorize as gospel, was suddenly local, conditional, and in at least one place, completely broken. And yet, the most unsettling feature of the Leda anomaly was its consistency. It didn't change with time, weather, or planetary alignment. Unlike magnetic fields or tectonic pressures, this force seemed indifferent to the world around it. It simply was. What do you call a place where gravity goes in reverse, but the world carries on as if nothing is wrong? Perhaps it's not a failure of science, but a reminder of its limits. A crack in the frame, not the picture. A suggestion that even the most enduring truths may one day need revision. Or maybe, in places like Leda, the universe lets slip a deeper order, one we've yet to understand, where gravity does not fall, but lifts. The forest was still. Just trees, moss, and the distant hum of wind brushing over northern Minnesota. Yet something in the air felt different, as if time had thickened, like syrup over stone. They called it Zone 7. Officially, it didn't exist. Unofficially, it was the site of a quiet panic among timekeeping experts. In 2003, a team tracking GPS drift noticed that atomic clocks brought into this 200-square-meter patch began falling behind. Not by much, just 3.7 seconds. But it was enough to break satellites, confuse positioning systems, and demand answers. Dr. Sarah Chen, a physicist from the National Institute of Standards and Technology, was among the first to investigate. With her came the world's most accurate timekeepers. Cesium-133 atomic clocks, devices so precise they could measure time to the billionth of a second. Inside the zone, they slowed, every time. Time, according to Einstein, can bend, but only under extraordinary circumstances. Near black holes, at light speed. But here, amid pine trees and loamy soil, time simply moved differently. There were no strange magnetic fields, no radiation, no gravitational anomalies. And yet clocks ticked out of sync, not broken, just unaligned with the rest of the world. Then came the plants. Botanists brought in saplings, seeds, and soil samples. The results were undeniable. Growth rates accelerated inside the zone. Trees showed rings inconsistent with the seasons. Leaves photosynthesized faster, as if tuned to a different sun. Even the people changed. Researchers stationed in the area experienced shifts in metabolism and sleep patterns. Circadian rhythms adjusted themselves to the flow of local time. DNA replication rates varied subtly. Cells lived in one clock while the world outside ticked to another. What troubled scientists most wasn't just the altered time, it was the precision of its boundaries. Step inside and your watch would lag. Step out and it kept pace with the rest of the world. The shift happened within a single meter, no gradient, no blending. Governments moved in. Fences appeared. Access became restricted. All ongoing studies were sealed. Dr. Chen's final public statement was chilling in its restraint. Time in Zone 7 is not broken. It is simply other. The phenomenon has never been publicly explained, but to those who work there, the conclusion became impossible to avoid. Time, like gravity, may not be universal. It might have edges, folds, seams, regions where it thickens or thins, hurries or hesitates. And if time can change its pace, what does that mean for memory, for aging, for history itself? In this quiet forest glade, nothing is louder than the tick of a clock that will not obey. And nothing is more terrifying than the possibility that time isn't a river at all, but a map with borders still unknown. The sky above the Nullarbor Plain is vast and ancient, but deep in its red heart lies a silence more profound than wind or wilderness. Here, in a stretch of the Australian outback, nearly 800 kilometers from Perth, electromagnetic waves vanish. They call it the Nullarbor Void, a 50-kilometer-wide region where radio signals die, satellites go blind, and electronics simply stop. It was first noticed in 1987 when telecommunications satellites began picking up a hole in their coverage, a place that didn't reflect, scatter, or absorb in any familiar way. Just pure black on radar, as if the land itself refused to be seen. Dr. Michael Thornton, a physicist from the Australian National University, led a field team into the zone. Their equipment failed instantly. Radios fell silent, GPS units froze. Even devices with no wireless capabilities, simple battery-powered instruments, ceased to function, not jammed, not blocked, just nullified. The boundary was abrupt. A signal approaching the perimeter didn't fade. It ended like a light bulb switching off. The edge traced the contours of the land with eerie precision, wrapping over rocks and dunes like a skin. Inside, there was no noise, no static, no interference. Only the absence of signal, as if the electromagnetic spectrum had been erased. And yet the human eye could see. Visible light, itself a form of electromagnetic radiation, passed through untouched. People could look into the zone and walk within it without distortion. But cameras failed to capture it. Infrared sensors read nothing. Satellite images showed a hole. Maxwell's equations, the elegant rules that describe how light and electromagnetism behave, didn't apply here. Every frequency researchers tested vanished without a trace, defying the idea that energy must go somewhere. No heat, no echo, no bounce. Just absorption without return. Geological surveys found nothing unusual. The rock beneath the zone was ancient limestone, dry and featureless. No magnetic ore, no conductive metals, no artificial structures. The land gave no hint of why it had erased one of nature's four fundamental forces. The government quickly stepped in. The region was declared a restricted military area. Maps were redrawn. The name was quietly scrubbed from public datasets. But in classified corridors, whispers spread. This was not interference. This was something deeper, a hole in the fabric that allows information to travel. What does it mean to have a place where the electromagnetic force simply disappears? Where light itself is selective, allowing only what nature chooses to remain. In an age ruled by signals and screens, the Nullarbor Void is a place that no signal can cross. And perhaps that silence isn't just technological, it may be a kind of message, that not all of the world wants to be seen, and some parts may be built not to reveal, but to erase. Beneath the surface of Geneva, in the basement of a quiet research facility not far from the Swiss-French border, a compass spun wildly on its axis, not because of malfunction, but because north had vanished. They called it Experimental Chamber 7, a square room lined with precision instruments, superconducting magnets, and a history of accidents. In 2008, during routine tests with magnetic levitation systems, researchers noticed something strange. Compass needles brought into the chamber pointed inward, toward the center of the room, no matter where they were placed. At first, it was dismissed as a calibration error, but more measurements followed. Magnetic field lines, which normally arc from north to south in graceful loops, here collapsed inward like the spokes of a wheel. The magnetic north no longer pointed to Earth's pole. It pointed to a void in the center of the chamber. Dr. Elena Vasquez of CERN led the quiet investigation. Her team found that the field defied every rule of magnetism. There were no poles, no external magnets, no flowing currents, just a persistent inward pull. Magnetic sensors became unreliable. Metal tools slipped from hands and clanged against the central floor. It was as if the room itself had become a magnet with no source. More unsettling still, the field changed depending on how it was measured. Instruments aligned one way recorded intense magnetism. Turned another, they saw almost none. It was as if the field responded to observation, reshaping itself based on attention. A place where measurement was not just recording, but participation. The phenomenon violated one of the cornerstones of electromagnetism, the idea that magnetic fields must form closed loops. Here, they didn't. They ended, or began. No one could say. Attempts to reproduce the effect elsewhere failed. No combination of coils, cryogenics, or configurations brought back the impossible field. Whatever had been created in that room, it had happened once, and then settled into permanence. Eventually, the chamber was sealed, not out of fear, but respect. Its walls were reinforced, its records redacted. It disappeared from the registry of active experiments, but those who worked there remembered it, not as a failure, but as a glimpse into something deeper than theory could touch. What if magnetic fields, like thoughts, can localize themselves? What if they aren't just products of electrons and spin, but phenomena that, under rare conditions, behave like something alive, reactive, perceptive, intentional? The reverse magnetism room does not scream its mystery. It hums, a low, invisible presence, one that bends needles, expectations, and perhaps the edges of known reality. In that stillness, a question remains. What happens when the forces that guide the world no longer follow the paths we drew for them? It started underground, deep beneath Sudbury, Ontario, where miners drilling through ancient rock began to notice something strange. Equipment became unpredictable. Machines weighed less near the floor and more when lifted. One operator joked that gravity was playing tricks. But the truth was far stranger. The site became known quietly as the Density Inversion Chamber. Discovered in 2012, it wasn't just a fluke of scale or balance. It was a space carved into Earth's crust where mass itself behaved differently. A 500-kilogram drill weighed just 300 near the floor, but over 700 near the ceiling. The object hadn't changed. The rules had. Dr. Amanda Price from the University of Toronto led the first scientific survey. Her instruments confirmed the impossible. Materials gained or lost mass depending on where they sat. Not weight, mass. That sacred, unchangeable property of matter was shifting as if in response to altitude. The deeper the object, the less of it there seemed to be. Water was the most revealing. Samples taken from the lower part of the chamber had a density 15% below normal. From the ceiling, denser than ice. The same liquid, physically moved, altered its state without temperature, pressure, or chemistry changing. Matter itself was becoming something else. The zone's boundary was a razor edge. Objects moved through it experienced sudden shifts, tipping over, breaking under unbalanced stress. Wood carbon dated at the floor level showed different results than when moved just a few meters up. Even atomic decay, the reliable heartbeat of radioactive elements, seemed disrupted. There were no unusual minerals, no radioactive ore, no magnetic interference, just empty rock and a chamber that twisted reality into something else. Officials sealed it quickly. A national security site, they said. Off limits. But for a brief time, the world had seen something it wasn't meant to. A place where conservation of mass and energy, the most unbreakable law in all of physics, simply didn't apply. What do we make of a room where being high means being heavier, where space changes what things are, not just where they are? Perhaps the universe isn't uniform after all. Maybe some corners of it operate by different scripts. Maybe matter remembers differently depending on its place in space. In the dark beneath Sudbury, the laws of matter slipped, and no one can explain why. The Nevada desert is a place of silence, of wide skies and wind-battered mesas. But northwest of Las Vegas, far from the reach of highways and hikers, lies a zone where silence takes on another meaning, where the rhythm of cause and effect breaks apart. It began in 1994 during weapons testing. A detonation recorded by high-speed cameras appeared to occur 2.3 seconds before the ignition command was sent. The footage was reviewed again and again. The instruments were checked, recalibrated, replaced. Still, the explosions happened before they were triggered. The site was sealed, studied, and eventually named only in private documents as the Causality Violation Zone. Dr. Jonathan Hayes from Los Alamos was among the first to accept the evidence. Time was misbehaving. Dropped objects hit the ground before being released. Lights turned on before switches were flipped. Computer calculations completed before their inputs were entered. Inside this 47.3-meter zone, cause followed effect, not the other way around. Events unfolded in reverse, not visibly, but functionally. A push did not cause a fall. The fall happened, and then came the push. It wasn't chaos. It was precise, consistent, and bounded. The moment one stepped outside the zone, time returned to normal. Inside, however, logic itself was upended. For the military, the implications were immediate. Devices were developed to monitor threats that hadn't yet occurred. Responses could be deployed before the danger emerged. But for researchers, the psychological toll was harder to manage. Some reported an eerie sense of inevitability, of being nudged by their own future actions. Decisions felt less like choices and more like following a path already walked. Free will became a question rather than a truth. No radiation, no strange particles, no known field caused the effect. It simply happened, within sharp, measurable boundaries. Attempts to simulate it failed. The phenomenon refused to travel. It lived only in that patch of desert, like a crack in the mirror of time. And so the zone was buried in secrecy. It became an asset, a mystery, and a warning all at once. What happens when time ceases to flow forward, when logic folds in on itself? Is the arrow of time absolute, or just our interpretation of a deeper rhythm we don't yet understand? In Nevada, one can walk into a space where consequences come first, and nothing is quite as certain ever again. Deep beneath the Swiss Alps, in a chamber no wider than a train car, something extraordinary happened. Light broke its own law. Project Spectrum was intended to be routine, another calibration run inside one of Europe's particle physics facilities. Lasers, mirrors, vacuum tubes. But the measurements were not routine. Red light and blue light, fired across equal distances, arrived at different times. The discrepancy wasn't subtle. It was undeniable. Hans Mueller stared at the data. Red light was moving 12% faster than the theoretical speed limit, the speed of light. Blue light, slower by 8%. The chamber had become a paradox, where Einstein's cosmic constant no longer held. They ran the tests again and again. Each time, the results were the same. But it wasn't just color that mattered. Direction did too. Light moving north to south traveled faster than light moving east to west. And these shifts weren't random. They changed with the rotation of the Earth. It was as if the chamber had become a privileged frame of reference, something relativity explicitly forbids. In Einstein's universe, there is no absolute, still no favored direction. But inside this space, there was. The implications were devastating. Information carried by these superluminal photons arrived before it was sent. Detectors fired before the signal began. Time, once again, was folding. It didn't stop at light. Other electromagnetic waves, microwaves, radio, even gamma rays, showed similar distortions. Their speeds bent and shifted, depending on wavelength and direction. Cameras failed to record it accurately. Sensors gave contradictory readings. It was as if the instruments themselves were caught in the anomaly. No known theory could explain it. No material, no curvature of space, no dark energy. Just light behaving in ways it never should. Project Spectrum was shut down quietly. International agreements buried the data. But those who had seen it couldn't forget that in one small chamber, the great limit of the universe had been breached. What does it mean when light, the fastest thing in existence, changes its pace? When information outruns time? When constants become variables? In this hidden lab, the very structure of space seemed to breathe differently. And for a fleeting moment, the universe sped up and slowed down, not because of distance, but because of place. In a remote stretch of northern Canada, tucked beneath layers of reinforced insulation and vibration-dampening walls, lies a room where quantum theory takes a breath and holds it. The quantum decoherence void wasn't built to break physics. It was designed to detect gravitational waves, ripples in space-time so subtle they pass through planets unnoticed. But something went wrong, or perhaps something went right in a way no one expected. It began with atoms. Instead of collapsing into definite states, as quantum particles always do when measured, they remained suspended in superposition, not for nanoseconds, but for hours, even days. Dr. Jennifer Walsh of the Institute for Quantum Computing was stunned. Under ordinary conditions, quantum states decohere almost instantly. They interact with their environment, lose their indeterminacy, and resolve into classical behavior, but not here. Inside the chamber, Schrödinger's cat stays both alive and dead, not metaphorically, but physically. The isolation was perfect. So perfect, in fact, that quantum entanglement broke. Pairs of entangled particles, normally bound across vast distances, lost connection when one entered the chamber. It was as if the room had become a world unto itself, cut off from the universal wave function that links everything else. It didn't stop with atoms. With crystals containing billions of particles held their quantum states. Biological molecules behaved differently. Some researchers even speculated that microtubules within neurons, tiny structures some theories linked to consciousness, were maintaining coherence longer than ever observed. Living organisms exposed to the space reported altered perceptions, not hallucinations, clarity, as if the fuzz of environmental noise had lifted, leaving only pure awareness. But such reports were quickly redacted. The transition into the void was absolute. Within a fraction of a millimeter, particles inside the chamber obeyed quantum rules in their purest form. Outside, they collapsed into classical certainty. The edge was sharp enough to split reality. No one knows why the chamber works. The design has been copied, but never replicated. The original remains classified, its coordinates erased. It exists in whispers and old conference notes that end abruptly. What if decoherence isn't inevitable? What if the classical world we live in is not the default, but the exception? A byproduct of noise and interaction, not a fundamental truth. Inside this room, the quantum world breathes without interference. And for a moment, reality waits. Undecided, unobserved, unbroken. High in the Atacama Desert, where the wind carves silence into stone, there lies a sealed laboratory where heat flows backward and disorder retreats. The thermodynamics reversal zone was discovered not through chaos, but through order. Researchers documenting closed-system energy behavior noticed something peculiar. Isolated systems weren't degrading, they were refining. Instead of entropy increasing, as every textbook demands, it was decreasing. In one experiment, two metal spheres of different temperatures were left in thermal contact. Instead of equalizing, the cold sphere grew colder while the warm one became hotter. No external energy was applied, no trick of measurement. The laws simply bent. Dr. Carlos Rodriguez, leading the Chilean research team, confirmed what should have been impossible. Entropy, the cornerstone of thermodynamics, the arrow of time itself, was running in reverse. Brownian motion, that restless jitter of molecules, changed too. Instead of chaotic dispersal, particles aligned, self-organized, and formed patterns as if guided by an unseen hand. At macro scales, systems separated themselves into perfect gradients of heat and order, drawing structure from equilibrium. They built engines. Simple ones at first, devices that, within the zone, extracted work from nothing but ambient heat, achieving efficiencies beyond 100%. Not perpetual motion, but something stranger, motion made possible by the reversal of natural decay. Biological systems reacted most dramatically. Cell cultures showed slowed aging, reduced mutation rates, and heightened metabolic efficiency. Living organisms, short-lived under normal conditions, thrived. The boundary of the zone was exact. Objects moved across it would instantly shift behavior. A cup of water on one side would cool as expected, slide it across the threshold, and it would begin heating itself. No electromagnetic fields, no unusual minerals, no gravitational anomalies. Just a room, a space, where time seemed to forget how to move forward. The site was closed, classified, and buried. International scientific bodies agreed to restrict access. Too many implications, too much risk. What if entropy isn't a law, but a suggestion? What if time doesn't always run downhill? In the stillness beneath the Atacama, the universe whispered a different rhythm. And for once, decay gave way to design. There is a place so secret it no longer has coordinates, erased from maps, removed from charts, forgotten on purpose. Known only as Anomalous Zone Alpha, it is not a building or a chamber, but a stretch of Earth where reality itself refuses to hold its shape. The first sign came in 2007. GPS systems showed wild inconsistencies. Satellites reported positional drift over a 10-kilometer radius with no apparent cause. When researchers arrived, they didn't find equipment failure. They found a hole in certainty. Inside the zone, the laws of physics fluctuate, not metaphorically, literally. Dr. Elena Kowalski, part of an international task force, documented the impossible. The speed of light varied by up to 15%. The gravitational constant shifted between 8 and 12 m/2, making objects fall faster or slower with no warning. The fine structure constant, the very key to how atoms form, drifted, threatening the stability of matter itself. Electronics failed first. Microprocessors require consistency. When the laws change faster than circuits can adapt, computation dies. Clocks became meaningless. Instruments showed different values every second. Then came the subjective effects. Researchers described warped perception, colors bleeding out of visibility, sounds changing tone without source, spatial relationships bent. A corridor that seemed short on entry stretched into impossible distance. Some described an eerie sense of being observed by the field itself, as if consciousness was not immune to the chaos. The zone breathed, expanding and contracting unpredictably. Sometimes it covered 50 square kilometers, sometimes only a few hectares. No rhythm, no pattern, just a pulsing instability in the weave of the universe. It was as if the fabric of space-time here had worn thin, frayed to the point of transparency. And beneath it lay something else, rules not of this world. No theory explains it, no equation holds. The constants that define reality are constant no longer. The site remains under perpetual surveillance from afar, its perimeter shifting like a tide no one can predict. What happens to a world where the rules fail, not once, but continuously? What if the laws of physics are not fixed truths, but local conditions, stable only where the universe remembers them? In Zone Alpha, reality forgets. And we are reminded that what we call natural law may only be habit. It began as a quiet anomaly in data logs, lines of code failing to execute in the correct order, events completing before they were initiated. At first, it was blamed on software errors. But the deeper researchers dug, the more it became clear this wasn't a glitch. It was a pattern. In a secure computing facility somewhere beneath Northern Europe, engineers stumbled into what would later be named the computational echo field. Unlike the other zones, this wasn't a physical distortion of space or time. It was informational. Commands were being processed retroactively. Data was arriving before it had been sent. Test routines confirmed it. Simple scripts displayed output milliseconds before input. Communication protocols logged pings that hadn't occurred. Even more unnerving, predictions made by the system about future inputs began to prove accurate, consistently. The machine was anticipating decisions. Dr. Linus Vogel, an expert in quantum computing, was brought in. He noted similarities to delayed choice experiments in physics, where particles seem to retroactively decide their states based on future measurements. But here, it wasn't particles, it was logic itself. The field existed only within the tightly enclosed data center. When hardware was relocated, the effect vanished. When returned, it reappeared. The boundaries were digital, not spatial, a kind of ghost in the circuit. Attempts to isolate the source led nowhere. No exotic materials, no external radiation. Just standard silicon, wiring, and algorithms behaving as if tethered to tomorrow. Eventually, the machines began generating information no one had requested. Results to unasked questions, solutions to unsolved problems. Some were useful, others were gibberish. But they all had one thing in common. They arrived ahead of time. The implications were dizzying. Was this a glimpse into backward causality? A computational equivalent of time reversal, or a flaw in the assumptions behind digital determinism? The facility was quietly reclassified. Research was halted publicly, but private efforts likely continue. What if information is not bound by the same time as matter? What if thought, logic, and decision live in a realm where causality can be stretched, where answers can precede questions? In this digital haunt, the future echoes back and asks if we're truly in charge of the machines we build, or if, somewhere in the wiring, time itself has begun to speak. The story ends where it perhaps always should, beneath our feet, across our skies, and within the hidden folds of the world we thought we knew. In a final location whose exact coordinates are classified, but whose implications are universal, researchers documented a field where constants, those bedrock values that define reality, fluctuate like candlelight in wind. This zone wasn't announced, it was inferred. Instruments stationed worldwide began picking up deviations, particle masses shifting slightly, Planck's constant nudging up or down, the charge of the electron wavering beyond acceptable error. Initially dismissed as calibration faults, the readings grew louder, more coherent. The anomaly was moving. Known only as the drift field, this final anomaly doesn't occupy a single location. It travels, sometimes rural, sometimes urban. It slides silently across the Earth's crust, altering the nature of physics wherever it rests. Satellite tracking revealed its path. It lingers for days, then vanishes. While present, it leaves subtle footprints. Chemical reactions that stall, batteries that drain faster, glass that bends under its own weight. and in rare cases, brief visual anomalies, colors not on any spectrum, shadows cast with no source. Dr. Maya Trenholm, part of a global anomalies task force, described it best. It's as if the universe blinks, just for a moment, and forgets the values it wrote into its code. What causes the drift field is unknown. It may be a natural feature, like tectonic plates, slow, vast, and indifferent. Or it may be something more. Evidence that the constants we consider sacred are context-dependent, flexible, and perhaps even negotiable. Whatever its nature, the field acts like a reminder that the stability we rely on is conditional. The laws we've written into textbooks are not carved into the bones of reality. They're whispers passed down by a universe that mostly plays fair, but not always. What does it mean to live in a world where light doesn't always move at light speed, where mass isn't always mass, and where time sometimes forgets which direction it's supposed to flow? In the drift field, the veil lifts, and the universe, for a fleeting instant, admits that it too is still becoming. Across mountains and deserts, sealed labs and silent forests, we've traced the outline of something extraordinary, a map of impossibility. These 13 places, each a contradiction, each a violation, form a constellation of questions that no equation can yet answer. Here, gravity reverses. There, time slows. In other corners, light races ahead of itself or disappears altogether. Some zones strip away magnetism, others rearrange mass, and a few tinker with the very constants that define reality. These aren't glitches, they're declarations, messages written in the margins of the cosmos, hinting that the universe is stranger than we dared imagine. But what binds them all is not science fiction or conspiracy. It is humility, a recognition that our models, beautiful though they are, remain incomplete. These anomalies are not failures of understanding. They are the invitations to deepen it. Perhaps these regions exist not to break the rules, but to remind us that rules evolve. That what we call natural law may be a local dialect in a larger, more complex language of reality. Governments classify, institutions conceal. But the silence surrounding these places isn't just about secrecy, it's about stability. Because if the laws of physics are not absolute, then what else might be negotiable? Memory? Identity? Time itself? For centuries, we've searched the skies for signs of the unknown, but perhaps the frontier lies not above, but within, beneath our feet and behind locked doors, in rooms where light curves wrong and clocks lose their grip. The question now is not whether these places exist. They do. The evidence is measured in seconds lost, masses shifted, and instruments that shiver with uncertainty. The question is, what do we do with that knowledge? Do we retreat into denial or step forward into the uncharted? In the end, these anomalies don't just challenge physics, they challenge our idea of permanence. They suggest that reality, like us, is in motion. That certainty is a comfort, not a fact. And so we close this journey not with an answer, but with a simple, enduring question. If the universe has rooms where its own rules dissolve, what might be waiting just beyond the ones we've yet to find?